Welcome to my lecture series on vector calculus. In the last class we have started the integration of a vector. So we have seen the basics of the integration. So today we will discuss line integral. So integration about a line. That means we will see the circulation of the fields, vector fields around a simple closed curve. So basically we will discuss today line integrals. Okay, fine. Let us see what is the line integral, then how we'll define it, and we'll take some examples to understand clearly. Okay, fine. So line integrals. Line integrals. Okay. Let us say I have a line. So I have a curve. So I'm taking a coordinate system. So very well known coordinate system, x-axis, y-axis, z-axis. Let's say this is the origin. Then I have a curve. Let's say which joins the points A and B. So I can have the position vector of A and I can have the position vector of B. Because this is the curve which joins. Let us P any point here. Let's say I'm taking a point P here. I can draw tangent at that particular point. Let's say the tangent to this curve will look like this. This is the tangent at that particular point. So I can say here. So we are taking, let R is the position vector which is a function of time. Time ane kaadu, ikka t is a parameter. Defines a smooth curve. Defines a smooth curve joining points A and B. Joining points A and B in space. Okay, then if I take any element here, so let us take this, I'll take an element dl or ds, dx, whatever it may be. Dl is the length of this element. Then the tangent vector, so tangent vector t will be is simply dr by dl. Okay, if we want the unit vector, we can calculate. So we are taking the r is a position vector, something like x component I cap plus y component j cap and z component k cap. So maybe here x is a function of some t parameter and y is also a function of some t parameter, z is also a function of some t parameter. So this is the vector function. Okay, fine. Now let us take a function. Let f be a function. Let f be a function. Let f again a function of t. So function of r and what is cheppachu because r itself is a function of t. Let f be a vector function defined along the curve C. F is a be a vector function. Vector function defined and continuous along the curve joining points A and B. Okay, so then the integral then the integral. So I am taking an integral, then the integral, let's say I, that is equal to integration of f dot, so f dot dl t cap. So t cap in the sense unit vector along the tangential direction. So or otherwise, what is f dot t cap will give component of this vector function along the tangential direction. Along the tangential direction. So we know that key this t will be is equal to dr upon dl. Okay. So from here I can write it as I will be is equal to integration of, this can be replaced with the dr, f dot dr. So this is important for us, f dot dr. F dot dr. Line integral, this is called the line integral of f along the curve C. This is called line integral of f along curve C, curve which is defined as r is a function of t. Okay, so that integral is important for us. See, these integrals can be even in other type also. Even so, the integral, even we can take a dot product, scale, a cross product also. Then I will be is equal to integration of f cross dr is also the line integral. Even if I can take the along the curve C, I can put here C means curve. Even I integration of phi dr, phi is a scalar function here, phi is a scalar function here dr. This is also the line integral along the curve C. Okay, fine. So sometimes we may have a closed curves, a closed curve. Closed curve integration will indicate like this. Put the circle here. It is for a closed curve. Okay. So that means initial point is same as that of closed point. Initial point is same as that of final point. Then we call as a closed curves. Okay. So for example, in Cartesian coordinate system, f can be written as, it has the x component, of course is a function of I cap, and y component is also there, and even z component is also there. And so what about dr? Dr will be dx I cap plus dy j cap and dz k cap. So when we take the product, so then that integration of f closed integration f dot dr will be is equal to, so when I take the dot product, I'll have simply fx dx plus fy dy plus fz dz. Even this can be written as for a curve also. Okay, fine. So finally, this integral is very familiar to you. In physics, you define the work done by a force. We define the work done by a force. So work done by a force. So work done by a force ela define chestam. Let us say, for example, I have a curve. Let's say there is a box is placed of mass m, there is a box, and it is going in this direction horizontally, and you are pulling with a force F in this direction. This is the force vector. Let's say this is the direction of displacement, it is moved from here to here. So let us call this will be the displacement L. then how will define the work done will be here. Here the work done will be defined as some F dot dr. F dot dr. So R is varying from, let's say this is the location, some R is equal to 0, and let's say this is the location, R is equal to some L. So going from R is equal to 0 to some R is equal to L. This is the work done. So work done by a force is the best example for circulation, best example for the line integral. Okay. So even other also there in Ampere's law. I will define the Ampere's law. In physics, we will define the Ampere's law like this. Ampere's law related to the magnetic fields. So circulation of magnetic field along a curve will be is equal to mu naught multiplied by current. So where B is the magnetic field circulated along a curve. Let's say this is the closed curve. So you can take the integral in any way. Let us take a small element here. This is the dl, length vector, dl vector. So now here there will be a magnetic field. So the magnetic field is also present. So you take the across this loop B dot dl, then I'll get as a mu naught into I. So this will be the integral. Even in so for example, not only these two, even another one is also there. What is the definition for a conservative force? The conservative force. Conservative force. So conservative force ఎలా define చేస్తాం? Work done for a closed path is 0. Work done for a closed path is 0. Work done for a closed path is 0. So that is work done for a closed path, that is F dot dr will be is equal to 0. So that means I have a closed path here. Let's say in 3-dimensional space x, y and z. So there is a closed path. The starting point is same as that of ending point. So I can carry the integration from this point and again I'll come back to the same point. So work done for closed path is 0, then the force is known as the conservative force. Like this, many examples will be there. So in engineering and science. Okay, fine. So let us take some problems, then you will understand clearly what it is actually. So without problems, it is not possible for you to understand very clearly what is the line integral. Let us take some examples. We'll take some examples. Let us take the problem as follows. So the problem, the first problem is find line integral, find the integration f dot dr along the curve that is given as f dot dr, where f is given as, so f is equal to xy I cap plus yz j cap plus zxk and the curve is defined as, the curve C is, the curve is defined as R is a function of t, that is t I cap plus t square j cap plus t cube k cap, where t is a parameter which is varying from, t is a parameter, t is varying from -1 to 1, -1 to 1. T is varying from -1 to 1. So this is the what we need to calculate here. So they have clearly mentioned, so the vector function, we need to calculate the circulation of that vector function along a line. So starting point is there and ending point is there. So they have given the curve R, which is a function of t. The function of t as follows. So that is function of t as follows, that is t I cap plus t square j cap plus t cube k cap. That means here x is t, y is equal to t square and z is equal to t cube. So this is what. Okay, so is the curve which is defined. So and f is also given. So we need to calculate integration of f dr by dt. Let's see elagana kocho chuddam. So f nu will convert into the parameter. So f is equal to, so they have given xy, x into y means that is t cube I cap plus y into z, that is t power 5 j cap plus z into x, that is t power 4 into k cap. This is the f. So now go for the integration, that is dr by dt. So f dot dr. So that integral we need to calculate along the curve, that is f dot dr. So now I can write f dot dr as like this, integration of f dot dr by dt multiplied by dt. So no problem because r is a function of time. So change of differentials. So with this here I have f is in terms of t, the parameter t, that is t cube I plus t power 5j plus t power 4k dot product with dr by dt. So dr by dt we need to calculate. So r is there, then dr by dt. So how to calculate the dr by dt? Just differentiate with respect to t. That is I cap plus 2t j cap plus 3t square k cap. So if I substitute here I cap plus 2t j cap plus 3t square k cap. Okay, so now there is a dot product, don't forget that dot product, and we need to integrate this entire thing with respect to parameter t, not necessarily time. So integration of I with I and j with j and k with k, t cube into 1, that is t cube, plus t power 5 into 2, that is 2 into t power 6, plus t power 4 into 3, 3 into t power 6 dt. Now entire thing is in terms of the parameter, that is varying from minus 1 to 1. So we get the definite integral. So what is the integration of t cube? The integration of t cube is t power 4 by 4 okay. So this is finally I will be is equal to minus 1 to 1 t cube plus 5t power 6 dt. The first integration I'll get as t power 4 by 4. Second integration I'll get as 5t power 7 by 7. Okay, put the limits. Upper limit is 1 and the lower limit is minus 1. First upper limit I will substitute, I'll get as 1 by 4 plus 5 by 7. Minus lower limit I'll get again 1 by 4 minus 5 by 7. So 1 by 4, 1 by 4 cancels, then answer will come as 10 by 7 units. So this is the way of calculating line integral along the curve. So ikkada curve anedi parameter lo icharu, x equal to t, y is equal to t square, z equal to t cube ani. You can get the relation between x, y, z. A curve nu manam giyali space lo, 3-dimensional space lo. Okay, that's not possible. Then you can take the simulations where you can express what is the nature of that curve. Okay, go for the second problem. The second problem as follows. Evaluate the integral. Evaluate the integral f dot dr where f is equal to 3x square I cap plus 2xz minus yj cap plus zk cap along the curve, that is along the straight line, from 0, 0, 0 origin to 2, 1, 3. This is the question. So let us see how to do this. Now we have to calculate the line integral along a line. They have defined the line as follows. So x, y, z. The first point will be 0, 0 here. That is the origin. Then another point will be here. That is 2, 1, 3. So this is the 0 and this is the point. You can say some a. So that will be they have mentioned it is a straight line. So what is the equation of straight line which is passing through the points? The equation of straight line, you must know this formula. Equation of straight line passing through points, let's say x0, y0, z0 and x1, y1, z1 passing through the points. So లేదా x1, y1, z1 అని చెప్పండి instead of x0. So let's say I can put it as x1, y1, z1, x2, y2, z2. Equation of right line passing through the points is given by so ఎలా చేయొచ్చు మనం? That will be the formula. So x minus x1 by x2 minus x1 is equal to y minus y1 by so y2 minus y1, z minus z1 by z2 minus z1 is equal to t. So parameter. So this formula you need to know. The straight line equation which is passing through the points x1, y1, z1, x2, y2, z2. You can say x1, y1, z1 is a 0, 0, x1, y1, z1 and these are the x2, y2, z2, x2, y2, z2. When I substitute this, so what is the formula I will get here? That is the straight line, that is the curve equation I will get directly. So that means here it is x minus 0 divided by 2 minus 0, y minus 0 divided by 1 minus 0, z minus 0 divided by 3 minus 0, that is equal to t. So from here what I'll get? I'll get the equation of the curve, that is straight line equation. So x is equal to 2t, y is equal to t, z is equal to 3t. This is the equation of the curve. Equation of the curve. That line in parametric form. Even you can put like this. R is a function of t. That is 2t I cap plus tj cap plus 3t k cap. We can put like this also. So once we know this, then we can go for the just like in the previous problem. So f dot dr. So we can go for f dot dr. So that integration I into f dot dr we require. So where f is given and dr by dt I can write like this. F dot dr by dt, r is a function of t into dt. Okay. Now when x is 0, 0, 0, t will be 0 here. So we know the points 0, 0, 0, 0. This time t will become 0. Then another one will be 2, 1, 3, 2, 1, 3. For this t will become 1. The parameter goes from 0 to 1 as a points go from origin 0, 0, 0 to 2, 1, 3. So okay, I have the r here. I want to calculate for dr by dt. Dr by dt will become 2i cap plus j cap plus 3k cap. So this is the equation of the curve, then followed by that's integration will become so dr by dt f dot, then what is the f is given 3x square I cap, but in place of x 2t is there, so 3 into x square means 2t, that is 4t square I cap plus 2xz. So 2xz, that is already 2t, 3t, 6t square, 12t square minus y, that is t, into j cap plus z k cap, that is 3t k cap. Then up to here I got the f. Dot product with dr by dt, that's above I have calculated. That is 2i cap plus j cap plus 3k cap into dt. Okay, fine. Now you take the dot product x with x and y with y and z with z. So then I will become, that is 12t square with 2, that is 24t square. So 12t square into 224. Then here j component, 12t square minus t with 1, that is plus 12t square minus t. So 12t square minus t. Then with k, that is 9t with dt. So t goes from lower limit is 0 and upper limit will be 1. Now 24t square and 12t square, 36t square. T 0 to 1. 36t square plus 8t dt. Okay. Now you do this. So 36t square ని మనం integrate చేద్దాం. t square integrate చేస్తే t cube by 3. Then I will become 36 into t square integration is t cube by 3. Lower limit is 0 and upper limit is 1 plus 8 into t చేస్తే t square by 2. Lower limit is 0 and upper limit is 1. So I is equal to, దీని నుంచి మనకి ఏమొస్తుంది, upper limit పెడితే 1 by 3, lower limit is 0. So that is 12 plus 1 by 2, that is 4. Then it will become 16 units. The answer is 16 unit. Okay. So this is the way of solving the problems. Even I can take the another problem also to do the problem. So let us take another problem. Let us take another problem. The problem as follows. If f is equal to 3x square plus 6y, 3x square plus 6y minus 14yz plus 20xz square k cap. Calculate integration along the curve f dot dr, line integral along the line, along the lines from, first one is 0 0 0 to 1 0 0, then second from 1 0 0 to 1 1 0, then third one is 1 1 0 to 1 1 1. So this is the problem. We need to calculate the integration. Okay, fine. Yeah, this here also our wish, we can take the curve equations, then in the parametric form we can do the integration, or otherwise a simple way you can get here. So let us solve the first integral. I'll solve it. So here we'll take simply so r vector in this dr vector. So r vector is x I cap plus y j cap plus z k cap. Then what about dr vector? So dr vector is equal to dx I cap plus dy j cap plus dz k cap. So here, so we need to do f dot dr. We need to do f dot dr. So here f dot dr. So it has a x component, it has a y component, it has a z component. That means x component dx plus y component dy plus z component dz. So now we need to perform the integration. Like this we can perform the integration. Okay. So here what is the x component? It is given in the problem. X component is 3x square plus 6y. 3x square plus 6y. What is the y component? Minus 14yz. Then what is the z component? 20xz square. So this is. So finally, go for the first problem. We need to do the integration for the first problem. 0, 0, 0 to 1, 0, 0. If you observe clearly here, x is varying from 0 to 1. But y is 0 and z is 0. So y is 0 in the sense dy is also 0. Z is 0 in the sense dz is also 0. So in our integration, if I substitute f dot dr here, integration f dot dr, that is fx dx plus fy dy, as dy is 0 and dz is 0, the only is left here fx dx. So but here fx is 3x square plus 6y into dx. But here again y is 0. So y is 0. ఎందుకని ఫస్ట్ కోఆర్డినేట్ 0 ఇక్కడ 0 అనేది ఎక్కడ పోతుంది 1 అంటే x is 0 to 1 కానీ y 0 0 y 0 గానే ఉంది z 0 గానే ఉంది సో y 0 సబ్స్టిట్యూట్ చేసామనుకో ఇక్కడ then what is left for me, that is I is equal to integration of 3x square dx. Now integration of 3x square will be x cube. So this is simply x cube, but lower limit is 0 and upper limit is 1, then that will be is equal to 1. So this is the answer for this. Let us go for the second question. So what is the second part of the question? It is going from 100 to 110. Second part of the problem will be 1002 to 110. So if you observe here, x is 1 and x is 1. So that is x is equal to 1. That is dx is equal to 0. No change in the x. Then y is going from 0 to 1. Y is going from 0 to 1. Then z you observe it is 0, 0. Z is 0. Then again in this integral we have integration fx dx plus fy dy plus fz dz. So దీంట్లో z is 0 కాబట్టి dz will be 0. So dx is 0 and dz is 0. Then what is remaining for us? So I will be is equal to integration of fy dy. So what is the fy here? In the problem fy is minus 14yz. Okay, so minus 14yz into dy, but z is 0 here. So but z is 0. So if I put z is 0 here, this entire integration will become 0. So the answer for this integration is 0. Then go for the third one. The third one will be, it is from 1 1 0 to 1 1 1 1 x1 y1 z1. So x is 1 and to 1 1 to 1, x is equal to 1, that implies dx is equal to 0, y equal to 1 1, that is y is equal to 1 in the sense dy is equal to 0, z equal to 0 1, z is equal to 0 to 1. So from here what I get, integration of fx dx plus fy dy plus fz dz. So ఇక్కడ dx 0 and even dy 0, dz fz మాత్రం ఉంది. So that is I is equal to integration of, what is the fz value here, that is 20xz square, 20xz square dz. So x is equal to 1 here. So if I substitute x equal to 1, then what I have, it will be is equal to 20z square dz. So what is the integration of z square will be z cube by 3, that is varying from 0 to 1. So I is equal to 20 into z square and z cube by 3, going 0 to 1, 1 by 3. Then I is equal to 20 by 3 units. I is equal to 20 by 3. Okay, fine. So this is the way of solving the problem. So ఇలా మనకు ఏ కర్వ్ ఇచ్చినా సరే మనకు ప్రాబ్లం అనేది మనం ఇలా సాల్వ్ చేయొచ్చు. ఓకే ఫైన్. Okay, so this examples I'll stop here. In the next class we can take few more examples. Okay, fine, thank you. So this is what actually the line integral. We will take the few more examples in the next class.